From the biomass that is left, that is the leafy and stalk material, we then move to what we've called here putrefaction. So this is a biological process, and of course putrefaction is what happens when, all of you who are gardeners will know it only too well, when you make a compost heap. It's an anaerobic process. Better to put a carpet over the top of your compost heap, and the process then goes on. The process consists of, it's an anaerobic digestion, and it consists of hydrolysis. So the first step is to break the cellulose down into sugars, simple sugars, acidogenesis, so turning this into carboxylic acids, acetogenesis, converting that to acetic acid, and then finally the process of methanogenesis, which is converting the acetic acid to methane. So from the process you produce methane, carbon dioxide, water, hydrogen, and the phosphorus and nitrogen compounds from the plant material. So the next point is that at this stage, having undergone the putrefaction, you take from the biogas the part of the material that is fixed nitrogen and phosphorus, and you put that into fertilizer. So I want to stress that in this cycle we are removing products at every stage so that we optimize the total process. You move on from the biogas and you come to catalytic partial oxidation. So here we're going to convert the methane by partial oxidation into a mixture of carbon monoxide and hydrogen. So let's just take a look at step one first of all. There we go. So we want to partially burn methane. We don't want carbon dioxide at this point, so it has to be done catalytically rather than by combustion, and it's done using the catalysts indicated there in blue. The rhodium, palladium, iridium or platinum are all good at driving this process. If you just look at methane dissociation and then coming to our supersonic molecular beam technique, this is the kind of result we get at to determine the detailed kinetics and dynamics of the breakdown of the methane molecule as it strikes the platinum surface, where with a supersonic beam we can control the translational energy of the molecule over the range indicated here, and follow the probability of dissociation for one collision of the molecule with the surface as a function of both the translational energy and the rotational energy, but also as a function of the surface temperature. This breakdown gives us a detailed understanding of what favors the dissociation of the methane molecule. And I can tell you that the breakdown is greatly assisted by a combination vibration excitation in the molecule, which we've just had proved using lasers, which is a stretch, a CH stretch, combined with the deformation mode, and that is the shape of the activated complex as the molecule begins to break down. Enough science. This is a slightly muddled slide, but what it says is that we also understand from our detailed analysis that the mechanism by which the CHX species on the surface go towards carbon monoxide on the surface is through an intermediate of CHO. This is a very recent and I think important discovery. So formyl is the critical intermediate, and we've also demonstrated that it's an intermediate in the synthesis of high hydrocarbons as well. So instead of going through dissociated CO, it's going through the formyl itself. And by using isotopic labeling, we can see that the CO desorbing from the surface derives from the CHO dissociation. So it also plays a role in hydrocarbon synthesis. Here's an excuse for showing a scanning tunneling microscope picture with molecular resolution. What you see is that if you try to absorb carbon monoxide on gold, you won't get any absorption at 77 Kelvin. But if you pre-expose the surface, for example, to NO2, but this applies to many other molecules, then the CO will co-adsorb on gold, and the co-adsorption forms, as the structure shows up here, a combination of CO and NO2 intimately mixed. It's ideal for reactive conditions. So this raises the question whether this metal that is mined out of mines in South Africa and put back into holes in the ground in Fort Knox could actually be put to some practical use for humanity.